All right. Good morning, everybody. I'm coming to you live from the Conard Math office, and we are going to take a look at a few factoring problems. These two problems that I'm going to do, they are found on page 5 of your Unit 0C packet. Unit 0C, and this is page number 5. Okay, so we're going to do problems 7 and 8, and some of you may have already had class, some of you have not, and that's okay. I just want to start off with two examples of factoring by grouping, and I'm ready to start factoring by grouping when I have three terms on one side of an equal sign of 0. So sometimes you might actually get part of the equation on the left and part of the equation on the right, and it will be your job to move everything over to one side. I always like to try and keep the coefficient of x squared positive. So if you see negative 2x squared on the left, you should just bring it over to the right or vice versa. Just try and get that x squared term to have a positive coefficient. Okay. Now, we are going to commonly start off by writing out a, c, and b. And I'm getting those variables from the general form of a quadratic. That's ax squared plus bx plus c. So as I look at this example, the AC would be 2 times 15. That's going to give me 30. And the b term in the middle is 13. Now, we are going to have to search for two numbers that when multiplied, they give us 30, and when added, they give us a sum of 13. So you might rack your brain a little while and think, what are two numbers that multiply to 30 and add to 13? I encourage you to pause the video right now, try and think of them, and we'll come back in a second. So pause and think of those two numbers. All right, did you think of them? The numbers are 10 and 3. Now, I know some of you were thinking 15 and 2, but it would have to have some kind of exchange of negative numbers to get us to like 15 plus negative 2, and that would give us a negative 30, not a positive 30. So 10 and 3 are those mystery numbers, and we're going to use these two numbers to break up our linear term. So we're going to rewrite the quadratic as 2x squared, and now we'll write plus 10x plus 3x plus 15, and that's equal to 0. Now, some people want to know, can I write it as 3x plus 10x? In other words, can I mix these two, the order? You can. They're going to give you a slightly different middle step, but your ending step will be the same. So once we make sure that we maintained equivalency, 13x, this is 13x, just written in a different way. I like to split it down the middle, and I'm looking for a common factor between 2x squared and 10x, and that's going to be 2x. So what would be left after I divide that out is x plus 5. And then we look over here, 3x and 15, they share a 3 together. So that's going to be 3 times x plus 5 equals 0. Informally, I like to call this right here matchy-matchy, because we have two binomials that are exactly the same, and that's going to allow us to combine the two terms that are outside of x plus 5. So I am going to use a little bit of color here. If you have two highlighters of different colors, I encourage you to use that right now. And we're going to rewrite the x plus 5 because both terms are multiplied by x plus 5. And then we're going to put those two together to make 2x plus 3 equals 0. Okay, so that is factoring that polynomial. And you just want to make sure that you understand that 2x squared plus 13x plus 15 is indeed equal to x plus 5 times 2x plus 3. So that is factored form. And if the directions say factor the polynomial, you are done. Okay, if the question said to solve, then you'd set each of these equal to 0 and get an actual x value. Okay, I'm going to go on to number 8. Same thing applies. We've got AC, and we're looking for the B, the middle term, and I'm seeing 3 times negative 4 to give me negative 12. B is equal to 1, and we're looking for two numbers that multiply to negative 12 and add to 1. Now, I'll give you a hint with this one. When you see that your B value is a low number, like 1 or 2, and the AC is negative, well, that means that the absolute value of those two numbers are going to be really close because we're either maybe adding negative 6 and 7, or we're adding 10 and negative 11, right? The difference between those two absolute values is only 1. So that's in my head telling me these numbers must be close. So I'm going to give you a chance to pause and look for those two numbers. So pause. All right, welcome back. What did you find? Hopefully you found 4 and negative 3. Those are the two numbers we're looking for, because when you add 4 and negative 3, you're going to get 1, and multiplied, you will find the product is negative 12. So we're going to rewrite this now. So I got 3x squared, and I'll give you a little hint. The factoring can work out better, and I mean better, just it kind of feels a little smoother when you pick a number over here that shares a factor with your first term. So 3x squared, I'm going to choose to write minus 3x and then follow along with plus 4x. You could do it the other way. It would be reversed, but your common factor would only be x. So then the binomial in the middle would have the non-1 coefficient. So I'm going to split this, and we're going to see a 3x in both of those. I'm left with x minus 1. And then 4x minus 4, you're going to say only a 4 can be found in common. So I'm going to set that equal. And the reason I'm writing equal to 0 is just because it was given to me like that. Traditionally, with factoring and expressions, we wouldn't even see an equal to 0. Okay, but last but not least, I'm going to, let's use our colors again. We see a 3x and a plus 4 are being multiplied by the same binomial. And that's, of course, our matchy-matchy x minus 1. So we're going to take 3x plus 4, and we're going to multiply it by that combined binomial of x minus 1. So that is the factored form. And those are two examples of factoring by grouping. So I hope that was helpful, and we will see you soon. All right. Have a good day.